Hi. For this lecture, we are going to discuss the last section in this chapter. So about Java collections linked list. And this is section 5 for linked list chapter. So in Java collections, it also provide the generic linked list, and we can go ahead and just directly use it. Okay, and for the linked list in Java collection is defined in the package of Java utility linked list, and you need to import it to use it. Okay. And for this linked list, it implements two interface, list interface and DAC interface. Okay. And what list interface provides, the method is regarding insert, remove, retrieve, and search. Okay, items anywhere in the collection. For DAC, it provides method for insert, remove, retrieve, at both ends of the collection. Okay. And because of this, linked list implement both list and DAC interface. And both list and DAC interface, they are sub-interface about iterable. So previously, we also discussed iterable interface. So in the Java collections linked list, it also supports the for each loop. Okay, as we discussed previously. And because of the definition of linked list in Java collections, it can be used to create objects, not just a linked list. Okay, it can also be used to create an instance of queue data structure or an instance of DAC data structure. So this is a general idea about linked list in Java collections package. So next, let's take a look the example code, okay, to have a better understanding. Okay, before we move to the example code, yeah, let's just directly go to the code. Yeah, and then we can come back to explain a little bit of more idea about something else. So in this example, as we previously mentioned, if you want to use Java collections linked list, you need to import import the respective package. Okay. And in this example, this is Java linked list example 4. Okay. In our textbook, we have 3 files. So the T clonable and the car Java, both of these 2 files are the same as in the Java linked list example 2, as we previously discussed. Okay, so we are going to go ahead to discuss about the application file. So in the application file, what we did. So if you recall the example 2, okay, we create a list of cars. Okay, so here similar. Yeah, but this time we also do linked list. But this linked list is from Java collections linked list. It's also a generic one. Okay. So here similar one for our first car is default, okay, and you add it. And we can check it. And after that, we just do add. And in Java collections, linked list, it's a little bit different from what we showed the add method. So here the add just add to the back because we didn't specify where we are going to insert. Okay. And then we can check. So all of the cards are the same as what we did in the previous example. And if you recall, in example 2, we have that copy list function. That copy list function did the deep copy. So Java collections linked list, its clone method also serves as deep copy. Okay, so if you want to do a deep copy of a linked list, you can call Java collection linked list is clone method. So this clone method is similar, has a similar functionality like our copy list from the second example. And similar, it also has that equals method. This equals method it does the structure equality check. So it will do the node by node comparison for its contents. Okay, so that's why here we use equals instead of the referential equality check. And similar, it also has a method to check if a specified item is contained in the list. So this method is called contains, okay? And it also has a remove method. So here, similar, we are going to remove car 4 if it does exist. After that, we can check, okay, if the car is removed from the first list, and we also going to check what's happened with the second linked list if this removing operation impact it. Is it a real deep copy? Okay. And after we run it, we will find it. And similar here, we also have this method, the get method, and you just pass in the position number. Okay, basically it's an index number to say, okay, oh, which car you want to get. Okay, so similar here. And you can also use iterator because this linked list implement the interface of list interface and the deck interface. And both of them, they are sub interface of iterable. Okay, so that's why this linked list in Java collections is also support iterables implementation. So it does have the iterator implementation, has next and next implementation. Okay, so you can directly go ahead to use it. So we call the iterator, okay, and with the iterator, you can get the iterator, okay. And then with the iterator, you can call the has next and next method. Okay. And if you find some, you can also remove it. So in this example, it will also demonstrate that if you're using iterator explicitly to do loop, then you are allowed. So you are allowed to remove inside the loop. And the loop will not be terminated. Yeah, we will run it and we will see it. Okay. So that's one of the nice feature. Okay. So if you do add or remove as it, and your operation won't be terminated. For the regular loop, the iteration, number of iteration is fixed. You cannot add a new item, okay, or remove an existing item. And also over here, we use a for each loop, okay, because of the iterable interface is implemented. And but we will say, okay, if you use for each loop, this may not work. Okay, we can check if it will work. So if it will not work, if the loop will be terminated, so that's why we have explicit iterator instance. And with this explicit one, then loop will not be terminated. Okay, with implicit, because it's for each loop, then there may be issue, okay, may be terminated. And then let's see. And the last two small section of the coding just show a very nice feature in Java collections linked list. Okay, and you can use this stream method call. Okay, and generally speaking, for string, you don't just use it independently. Normally, after it, uh, it has the stream method return the string interface. Okay, and with this interface, then it also has a number of functions that you can go ahead to use. And this for each function is one of it. So basically, it also supports the loop, okay? And this is different from that iterables for each loop, okay? So this is explicit a function call for each, okay? And within it, you can provide a lambda expression, okay? And over here is you want to try to output something, okay, for each of the elements. And like over here, it explains for this stream, it is support the sequence of elements for sequential and parallel aggregation operations. Okay, it also supports parallel. Okay, so that's a nice feature. Okay, later on we may explain it. And for the second part is after the string we call filter. So from the linked list, you try to find out some nodes that have some features. You want to get them out. And what this filter returns string also. Okay, so that's why over here you can chain go ahead to continue to use the for each function for the loop. Okay, and then within it, so similar, you can plug in lambda expression, okay, because for each and the filter, what they take in as functional interface. And previously, we also explained functional interface. It has a single abstract method. Okay, so that's why you can use a lambda expression to implement it. Okay, so that's regarding this example, and we can run it and take a quick look to see what the running result is and if it matches what we expected. Okay. Okay, the first, let's see. So this part is the same, is it? And then you have the bunch of cards, so it's all add one by one to each other. And for the second list, you can see the clone method does create a deep copy, exact the same copy, okay, of the um, first one. And then it says after removing one car, I remember it's car 4, is it? You can see the original list, car 4 doesn't exist, okay? But let's see the second list. The second list, car 4 still exists. So this does prove, verify that the clone method in linked list is a deep copy. And then let's continue. You see here, we use the iterator for the loop, is it? And we did do the remove operation, but you can see the loop is not terminated, okay? And then we use for each loop, okay? And you can see the car 3 is already removed, okay? And the following is just that function for each and the filter for the string related operation. And here we can also go ahead to check if this part works. If we do, so if it's a car 3, okay, and then we are going to remove it. But you see, after we comment out, basically, uh, here the compiler itself also gave kind of warning that over here says it is suspicious call to the remove. Okay, and but we can also try, okay, because it says suspicious because the type is car, okay, actual type is object. So let's see if it is this caused the problem or if it is for each loop will have some problem, okay, some issue. Okay, then in this case, if we take a look, the running result. Okay, the running result, so remove doesn't affect, okay. If we take a look using the for each loop, that and within the for each we did call the remove. So car 3 did get removed, but the loop is not terminated. So loop not terminated. Okay. So that's because in the Java collections, iterable interface, it has it supports the remove method, and the remove method did get implemented, and so there is no issue. So this version, so Java collections, linked list, the implicit for each loop also support remove operation. Okay, so the loop will not be terminated. Okay, so that's a nice thing. Okay, so we complete the discussion of the example of the linked list in Java collection. Okay, so what next? A little bit of left. I wanted to go over. So let's take a look. Okay, see here. Yeah, it's regarding the Java linked list in Java documentation. Okay, so let's take a quick look. So this is DAG. Now this is collection. Okay, so if you recall, previously we said linked list, but we can also see this here. Yeah. Linked list is it does implement the list interface, okay. And you can also say list interface, the super interface include iterable, okay. And then let's scroll down. For the list interface, if you take a, you will see it has the add function. Add and add all. Okay, those method contains equals. Let's see if it also has the iterator method. Okay, it also has a list iterator. So the difference between this and list iterator is a two-way iterator, not just a one-way iterator. And some other. And if you take a look, it will also say because of the super interface collection, it supports the stream. Um, it supports the stream operation. Okay, so that's regarding Java documentations list. And similar for the DAC, as a DAC, and if you see this implement class is linked list, okay. And the linked list, it's linked list, and its super interface includes iterable and collection, okay. And for DAC, then its operation, it has the operation of add first. So it's only the operation on both ends, okay, not in the middle. And because we see the collection interface, okay, in both list interface and DAC interface. So collection, it's a super interface. It's iterable, okay, iterable. And for collection interface, then you can see it has like the add method and also has a remove method and iterator, okay, method. And for the iterator method, and we can also go ahead to take a look iterator interface. Is it for iterator interface? Its method is has next, next, and remove. Okay, so that's why it supports the remove operation. Okay. Mm. Okay, so that's the information regarding Java collections linked list. So we we kind of complete this chapter, and in our next lecture we will discuss a new concept. So bye.